Hi, this is Mr. Evans again, and for our final video in our energy unit, I'm going to be talking about incomplete transfer of energy. And so what I mean by this is that, we've done all these roller coaster problems, and we're going to continue to do them, but all our roller coasters have been very boring. Okay, we've gone from on top of the roller coaster and then down to the ground. Okay, and so we have our roller coaster up here. Now, boring and not all that exciting. And so what we're going to do now is let's talk about, well, what if we go back up a hill? Or I want to know what's going on when we're not at the bottom of the hill and we're somewhere else. And so let's go ahead and do this. And so let's say this is point B, and I want to know what our kinetic, or actually, I want to know what our velocity is at point B. Okay. Now, I do need to give you some background information. So let's say our cart is 650 kilograms. Let's say our first hill is 50 meters off the ground. And let's say our second hill is 15 meters off the ground. Alright, so we need to figure out the velocity on the second hill. Now, previously, you should have been able to solve for the velocity right here, because it's all become kinetic energy. The issue is the cart has clearly slowed down as it begins to go back up the second hill. And so with that in mind, we need to solve for its new, slower velocity. So to do this, we're going to start out similar to how we do the transfer of energy, is we need to know our total energy. And so again, I am assuming that my maximum energy occurs right here at the top of the hill. And so my potential energy is 650 times 9.81 times 50. And so at the top of the hill, I have a total energy of 318,825. Okay, so that's how much I would also have at the bottom of the hill. The issue is I'm no longer at the bottom of the hill. And so what I want to solve for now is how much potential energy exists on my second hill. And so let's do hill 2 equals still 650, still 9.81, but we're only 15 meters off the ground. And so hill 2 possesses 95,647 joules. So if I have 95,647 joules of potential energy here, 318,825 joules of potential energy at the top of the hill, where did the rest of my energy go? And the answer is, that means the rest of the energy is kinetic energy, and so my kinetic energy equals 318,825 minus 95,647. So that means at that point on the hill, I still have 223,177 joules of energy. So now that I know how much kinetic energy I have, do you guys have any idea what to do next? Yeah, so the next thing I'm going to do is plug that into my kinetic energy equation, because I'm trying to solve for velocity. And so if kinetic energy is 1/2 mv squared, I know that I have 223,177 joules of kinetic energy. I still have a mass of 650, and I need to solve for V. Okay, so that means this side ends up equaling 325 V squared. I divide 325 to the other side, and that's going to get me 686.7 equals V squared. And so I simply square root it, and my final answer is 26.2 meters per second. So that is how fast I'm moving at the top of the second hill. Now, the only way I could make this harder, and believe me, I will, is to start including more energy at the beginning. And so by more energy, I don't mean a bigger hill, okay, because that's still the same math. And what I mean is, let's say we have a second hill here, and I don't know if I'll get through all this problem because it will be a lot of math to try to show on this little screen. So similarly, I'm going to start on a hill, and let's say this hill, let's even say it's shorter. Let's say this hill's 30 meters. My second hill is 10 meters. Okay, I want to know the velocity on the second hill, and my cart weighs 540 kilograms, and it was shot off the hill, so it got a speed boost, which is totally a thing on roller coasters, at 10 meters a second, because just going down the hill was too boring. So we're going to shoot this roller coaster off the hill. Now, just to get this question started for you, what you're actually doing, since we're assuming no loss of energy, and again, that would be the way I could make this even harder, would also be to include loss of energy, but we'll combine that maybe in class, is the actual equation you have is potential energy 1 plus kinetic energy 1 equals potential energy 2 plus kinetic energy 2. And so this is point 2, this is point 1. So all I need to do is solve for what I know. I can solve for the potential energy at point 1, just like I can solve for the kinetic energy at point 1. Okay? I can add those two numbers together and get total energy from the start, which is then going to equal my potential energy and kinetic energy at the finish. Okay? Again, I can solve for potential energy at the finish. I have my height and I have my mass. So what you end up doing is total minus potential energy 2 equals kinetic energy. Once you have this kinetic energy number, hopefully you've gotten used to this, you plug it into your kinetic energy equation and you can solve for velocity. And so I'm going to go ahead on Edpuzzle here and give you a question to hopefully practice using this equation and keeping it in mind, and you should hopefully be able to get the right answer, and we will obviously work on this moving into the future. So hopefully you've enjoyed the energy unit, and we'll continue to practice in class.